The story begins with an unsettling what if. A black hole, silent and invisible, drifting into our solar system. Imagine the universe's ultimate vacuum cleaner casually pulling up to our celestial neighborhood, like a cosmic Roomba that forgot its off switch. It doesn't buzz or glow or announce itself. It just glides through the blackness, bending space like a heavyweight leaning on a trampoline. You wouldn't see it coming, you wouldn't hear it arrive, and by the time you realized it was here, your world would already be trembling under its invisible pull. Picture this. One night, the world's telescopes start picking up strange distortions in starlight. Light that suddenly bends in ways it shouldn't. At first, astronomers might think it's a glitch, maybe a sensor issue. But then it happens again. Stars that should appear steady start to wobble slightly, as though someone is stirring the cosmic soup. Soon, data from multiple observatories around the world confirm the impossible. Something massive, unseen, and moving fast is warping the fabric of space itself. This would be the moment humanity collectively leans closer to its screens and whispers, "Wait, what is that?" Good evening, curious minds. I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing, but only if you enjoy these calm journeys through the universe. Now, let's begin. To grasp how big of a deal this is, we need to remember what a black hole really is. The ghost of a once mighty star. A remnant so dense that it's no longer part of our normal universe. It's a hole in it. Think of space as a stretched sheet, and a black hole as someone dropping a bowling ball onto that sheet, except this bowling ball doesn't just make a dent, it punches a hole straight through. The scariest part? You can't patch it. You can't even see it. All you can see is the chaos it causes to everything around it. Now, for this story, let's imagine it's a rogue black hole. Most black holes stay in place, anchored at the center of the galaxies like cosmic anchors holding their swirling star systems together. But a rogue one? That's a wanderer. It might have been kicked out of its home galaxy during a collision or gravitational brawl, now drifting through the emptiness between stars like a cosmic hitchhiker. These rogues are rare, but not impossible. Astronomers estimate there could be hundreds of millions of them, quietly roaming the Milky Way right now. Think about that. Hundreds of millions of invisible monsters, just passing by in the dark. Sleep well. As our black hole glides toward the solar system, nothing about it would appear dramatic at first. It's not like in movies where space starts glowing red and the planets shake in slow motion. Nope, space is far too calm for that. This would begin as a whisper, a soft distortion, a subtle bending of the sun's gravitational threads. Maybe some comets out near the edges of the solar system start to act strange, drifting from their usual paths. Astronomers would notice the oddity, scratch their heads, and try to make sense of it. Then the realization would dawn. Something incredibly massive is on approach, and it's not reflecting light. The idea of an invisible visitor that can bend light itself is both awe-inspiring and deeply unsettling. It's like finding out there's an elephant in your living room because your furniture started floating, but you still can't see the elephant. And this one doesn't stop to say hello. It just keeps moving, dragging the very fabric of reality behind it. At first, public reaction would probably split in two directions: panic and memes. Social media would erupt with "Had Black Hole 2025" jokes, people making t-shirts with Event Horizon, more like End of Season, printed across them. Meanwhile, scientists would be frantically calculating trajectories and probabilities. Where is it headed? How close will it come? Could it swing by harmlessly? Or is it on a collision course with everything we know? The truth is, even if the black hole only passes near the solar system, the gravitational chaos it would cause could rewrite the orbits of planets and fling asteroids around like confetti. But at this stage in the story, no one knows that yet. We're still in the eerie calm before the cosmic storm, the realization that something enormous and ancient is moving toward us, and all we can do is watch. This is where humanity's imagination kicks in. Artists render what it might look like: a black sphere surrounded by a halo of distorted starlight, as though reality itself is melting around it. News outlets call it the cosmic intruder. Late-night hosts make jokes about black holes being the universe's delete button. But behind the humor is a creeping unease. We're dealing with something that doesn't play by the rules of ordinary physics. And perhaps the strangest thing of all is how quietly it happens. No explosions, no flashes, just silence. The most dangerous thing in the universe makes its entrance not with thunder, but with gravity's slow, inevitable pull. It doesn't want attention. It just exists. An ancient leftover from the death of stars, indifferent to our fears, our science, our existence. As the chapter closes, the camera of imagination pulls back. Our tiny blue planet still spinning peacefully under the sun, utterly unaware that somewhere out there something is coming. The black hole keeps drifting closer, invisible yet unstoppable. And for the first time in human history, we might be forced to look directly into the heart of cosmic darkness and ask, what happens when the void looks back? A black hole begins life as something far less terrifying: a star. Not just any star, though. One of those massive ones that burn through their fuel like a teenager with a new credit card. These stellar giants live fast, die young, and go out with the kind of bang that makes fireworks look like polite applause. Once they've used up all their nuclear fuel, they lose the one thing keeping them stable: pressure. Without the energy from fusion pushing outward, gravity, ever the overachiever, wins. The star collapses inward under its own weight, squeezing billions of tons of matter into a point so small it might as well not exist. That's the birth of a black hole. A cosmic implosion so extreme that it creates a region where the rules of physics stop making sense. Imagine taking the mass of several suns and cramming it into something smaller than a city. The density is beyond comprehension. A teaspoon of black hole would weigh more than Mount Everest doing squats while carrying Jupiter on its back. It's the universe's way of saying, I bet you can't even imagine this. And it's right, we really can't. So, what actually happens at the core of a black hole? Well, physicists call it a singularity, which is science speak for we have absolutely no idea, but it's definitely something wild. It's the point where all that mass collapses into infinite density. Around it lies the event horizon, the ultimate cosmic border. Once you cross that line, not even light can escape. And since light is the fastest thing in the universe, if it can't get out, you can bet nothing else will. The event horizon isn't a physical surface. It's more like a trapdoor in space-time. From the outside, it looks like a black sphere, perfectly smooth and eerily featureless. It's the cosmic equivalent of a 404 reality not found error. But despite how movies love to portray them, black holes aren't cosmic vacuum cleaners that suck everything into oblivion. They don't go around hoovering up galaxies. In fact, if you replace the Sun with a black hole of equal mass, Earth would keep orbiting just fine. It would just get a lot colder and much darker, and your solar panels would have a nervous breakdown. Black holes pull things in only when you get close enough that the gravity becomes irresistible. It's less like being vacuumed up and more like getting caught in the ultimate gravitational slip and slide. One of the strangest things about black holes is how they mess with time itself. According to Einstein's theory of relativity, gravity isn't just a force, it's the bending of space-time. And black holes bend it so severely that near their edges, time slows down. If you could watch someone fall into one and somehow not fall yourself, you'd see them appear to freeze in place, their motion stretching slower and slower until they vanish from view. From their perspective, though, they'd continue right through, unaware of the distortion. It's the ultimate cosmic prank. Two versions of time happening at once, both technically correct. And then there's Hawking radiation, the universe's way of giving black holes a slow leak. Stephen Hawking showed that black holes aren't entirely black. They actually emit tiny amounts of radiation due to quantum effects near the event horizon. Over unimaginably long timescales, they can evaporate completely. Imagine the most patient candle in existence, burning for trillions of years before finally flickering out. It's poetic, really. The most voracious eater in the universe slowly starves to death. Not all black holes are created equal, though. There are stellar mass ones, formed from collapsing stars. And then there are the supermassive ones, lurking at the centers of the galaxies, millions or even billions of times heavier than the Sun. These monsters control the dance of stars around them, like cosmic conductors with a very dark sense of rhythm. Astronomers believe almost every galaxy has one, including ours. At the center of the Milky Way lies Sagittarius A, a black hole so massive it could swallow 4 million suns, yet so calm it's practically napping. If it ever sneezed, half the galaxy would feel it. Then there are the weird cousins, the intermediate mass black holes, too big to be formed from single stars but too small to anchor galaxies, and the theoretical primordial ones that might have formed moments after the Big Bang. Some of those could be no larger than atoms, but with the mass of mountains. Space, apparently, doesn't do half measures. Now, let's talk about the visuals. Despite being invisible, black holes are surrounded by some of the most stunning sights in the universe. When matter falls toward them, it forms an accretion disk, a glowing whirlpool of gas and dust spiraling inward at nearly the speed of light. Friction and gravitational energy heat this material until it shines brighter than entire galaxies. It's a paradox of beauty and destruction. The closer matter gets to death, the more spectacularly it glows. If you've ever seen the image of the black hole captured by the Event Horizon Telescope, that fiery ring of light is the accretion disk glowing furiously, while the center remains utterly black. So, meet the monster, an object that defies explanation, a cosmic paradox that eats matter, bends time, and challenges everything we think we know about the universe. It's elegant, terrifying, and strangely majestic. And, while it might sound like pure science fiction, it's real. They're out there, drifting through the void, some hiding at the hearts of galaxies, others wandering freely like interstellar sharks. And if one of them happens to be heading our way, well, we'll just have to hope it's feeling full. A rogue black hole is what happens when a stellar heavyweight loses its home address. During the violent collision of two galaxies, or the messy breakup of a binary star system, one black hole can get kicked away, ejected at tremendous speeds. With nothing tethering it to a galactic center, it becomes a wanderer, drifting through interstellar space like a cosmic vagabond. The Milky Way alone could be hiding hundreds of millions of these invisible nomads, each silently plowing through the darkness with the subtle menace of a predator we can't see. Now, space is big, absurdly, incomprehensibly big. The distance between stars is so vast that even traveling at thousands of kilometers per second, a rogue black hole might take millions of years to cross from one end of the galaxy to the other. But time doesn't care about our schedules. Somewhere, one of these invisible wanderers could already be on an intersecting path with our solar system, gliding toward us without a whisper of warning. So how would we even know? The first clues wouldn't come from seeing the black hole itself, because, well, that's impossible, but from what it does to the light behind it. Black holes warp space, and light follows the curves of space like a car following a winding mountain road. So, when light from distant stars passes near a black hole, it bends around it, sometimes even forming a ring of light known as an Einstein ring. Astronomers call this phenomenon gravitational lensing. It's the universe's greatest magic trick, making light curve, twist, and multiply in impossible ways. Imagine stargazing and noticing something odd. One star suddenly appears brighter, stretched slightly as though it's being pulled by invisible fingers. Then it fades back to normal. To most people, that would be a shrug-worthy curiosity, but to astronomers, it's a smoking gun. That flicker, that brief bending of light, might be the signature of a rogue black hole passing between us and that distant star. It's as if the universe blinked, and for a moment, reality itself bent out of shape. That's how we'd first detect our cosmic intruder, not by sight, but by its gravitational handwriting scrawled across the canvas of starlight. NASA has already spotted a few potential rogue black holes this way. One particular candidate, drifting about 5,000 light-years away, revealed itself not through light, but through the way it warped the light of a background star for several weeks. To most of the universe, it was just another shadow passing in the dark. To us, it was confirmation that invisible monsters really do wander out there. But even knowing that doesn't make the idea less terrifying, because once a rogue black hole starts approaching the solar system, it doesn't announce itself. There's no cosmic trumpet, no shimmering glow on the horizon. Just small, almost unnoticeable oddities that begin to add up. Maybe a few comets in the distant Oort Cloud shift their orbits slightly. Maybe our best telescopes notice that the paths of a few outer objects, small icy bodies far beyond Neptune, start to drift in a way that defies explanation. Astronomers check their math, then check it again. Something, somewhere, is tugging on our solar system's edge. For a while, no one panics. Space is full of mysteries. Gravitational anomalies, invisible clouds of dark matter, or miscalculations in orbital models. But then the pattern strengthens. The tug is growing. Something massive is approaching from the direction of deep space, and it's not reflecting light. That's when the scientific world collectively gulps. The first press release would probably sound calm, even reassuring. Astronomers have detected a massive, unseen object moving toward our solar system. Its trajectory is uncertain, but there is no immediate danger. The word immediate would do a lot of heavy lifting there. Meanwhile, behind the scenes, the data analysts and physicists would be in full-blown overdrive, running simulations to predict the newcomer's path. Every result would come back with the same quiet conclusion. This thing is big. As the black hole draws closer, its gravitational influence becomes more pronounced. It begins to subtly stretch the web of gravity that holds our solar system together. But here's the haunting part. There's still no way to see it directly. It doesn't glow, doesn't emit heat, and doesn't scatter light. Even at the edge of the solar system, it would remain invisible against the background stars. The only sign of its presence would be the distortions it leaves behind, like footprints in the fabric of space. You could imagine scientists pointing their telescopes toward the region of sky where the anomaly seems strongest, searching for anything, any flickers, any bend, any sign that light is being pulled astray. And when they find it, they'll realize they've been staring into the eyes of something that doesn't blink. What makes this stage of the story so unnerving isn't the destruction, it's the silence. The black hole doesn't roar, it doesn't crash into things like a cosmic wrecking ball. It's smooth, efficient, and eerily patient. It doesn't need to chase its prey, it simply exists, and space itself moves to accommodate its will. As the chapter closes, imagine Earth from space. A blue marble orbiting in quiet harmony around its golden star. Everything looks peaceful. But somewhere far out in the void, spacetime is beginning to twist. The invisible traveler keeps gliding forward, unbothered, unstoppable. And though no one can see it yet, the black hole is writing its arrival in the language of gravity. The cosmos doesn't always shout its warnings. Sometimes it whispers them. And by the time we learn to listen, the silence has already arrived. At first, the changes are subtle. Neptune's orbit wobbles by a hair's breadth. The outermost comets begin to deviate from their long, looping paths. Nothing dramatic yet, just the kind of anomalies that make scientists squint at their data and say, "That's weird." But weird is how all great discoveries start. Within weeks, those tiny orbital quirks multiply. Calculations that once lined up perfectly with predictions begin to unravel. It's as if someone grabbed the edges of the solar system and gave it a gentle shake. Astronomers, of course, don't panic right away. They check for alternative explanations. Maybe a hidden dwarf planet is responsible, something like the mysterious Planet 9 that's been theorized for years. Or maybe it's an error in instrumentation. Computers are rerun, simulations are refined, and still, the math won't cooperate. Something massive, something unseen, is tugging on the farthest reaches of our sun's domain. Neptune, that deep blue sentinel of the outer solar system, becomes the first major indicator that something's off. It's orbiting just a little too fast in some regions and a little too slow in others, like a dancer who can't keep time with the music anymore. Astronomers measure the deviations down to the decimal and realize the planet is being nudged, not by a nearby world, but by something much farther away. Its gravitational fingerprint doesn't match anything we know. That's when a few scientists, the brave, or perhaps the reckless, whisper the terrifying possibility. A black hole is passing close enough to disturb the solar system's balance. Meanwhile, the comets out in the Oort Cloud, the vast, icy shell that marks the edge of our sun's gravitational influence, start behaving like they've had too much caffeine. Their slow, stately drifts become chaotic. Some are slingshotted outward into deep space, never to return. Others are hurled inward, destined to light up our skies in the millennia to come. It's like watching a snow globe after someone gives it a furious shake. Thousands of glittering particles swirling unpredictably, except each snowflake is a 10-kilometer wide block of rock and ice moving at thousands of kilometers per hour. On Earth, telescopes record the growing oddities. The data pours in, and the graphs start looking like they've been drawn by someone with a nervous twitch. Gravity, that most reliable of cosmic forces, seems to be misbehaving. It's as if the solar system's GPS suddenly got drunk. Planets are drifting off course, orbital predictions are failing, and every space agency's flight path calculations for distant probes now come with a side of existential dread. Somewhere in a dimly lit observatory, a scientist stares at a monitor, rubs their eyes, and mutters, "This can't be right." Spoiler, it is. As the invisible visitor draws closer, its gravitational pull doesn't just act on individual bodies, it stretches space-time itself. Think of the solar system as a calm pond. For billions of years, gravity's ripples have been gentle, circular waves radiating from the sun. Now, the black hole's approach is like a massive rock plunging into that pond. The ripples interfere, collide, and amplify each other. The entire solar system feels the disturbance, even if most of it doesn't yet understand what's happening. If you were floating somewhere near Neptune, the effects would be eerie but strangely beautiful. The stars would appear slightly distorted, their positions bending subtly as light curved around the invisible mass intruding nearby. Space itself would seem to shimmer, like heat haze over a desert. You wouldn't hear anything. Sound can't travel through space, but you might feel it in the numbers if you were measuring gravitational fields. The black hole would still be impossibly far away, yet its influence would already be rewriting the physics of our backyard. And, of course, on Earth, the discovery would explode across every headline imaginable. Space-time distorted, mysterious force tugging on outer planets. Scientists would rush to appear on talk shows, each trying to explain the situation with varying degrees of calm professionalism. Someone would inevitably compare it to a cosmic flyby, while others would quietly admit that, well, there's a small chance it could get worse. Panic wouldn't set in yet, but the unease would be palpable. Humanity's collective curiosity would mix with a creeping realization. something enormous and invisible is interacting with our solar system. Deep space missions like Voyager 2, still sending faint signals from the edge of interstellar space, might detect subtle shifts in trajectory as well. The tiny change in their paths would be like a whisper from the void. A gravitational hello from an object that doesn't want to be found. Engineers on Earth would pore over telemetry data, adjusting for anomalies. But there's no adjusting for a distortion in spacetime. As the ripples spread inward, the sun itself might start to feel the difference. Not directly, it's still far too massive and dominant, but the balance that keeps all the planets in their stable orbits begins to warp. The solar system, usually so perfectly tuned, is now out of sync, humming to a new gravitational melody. Humor, of course, would still find its way into the chaos. Astronomers joke to cope. Someone on social media coins the hashtag Neptune needs a shoulder, while another memes the situation with Pluto's revenge. Because when the laws of the universe start glitching, laughter is our last defense against the panic that follows. But beneath the jokes, the truth is sobering. The black hole's gravity is reshaping our solar neighborhood, and there's nothing anyone can do to stop it. No rocket, no shield, no technology can alter the fabric of space. It's like trying to stop the tide by yelling at the ocean. And so, as the data mounts and the ripples spread, one thing becomes painfully clear. The visitor isn't just passing by anymore. It's entering our domain. The outer planets are already whispering their warnings through orbital shifts and strange deviations. The calm, predictable harmony of the solar system is officially broken. Something massive is moving closer. And gravity, the universe's most patient force, is just beginning to show us what happens when it's stirred by a passing monster. For billions of years, the outer planets have been the quiet sentinels of the solar system. Slow, stately giants orbiting far from the sun's warmth, rarely disturbed by the chaos of the inner worlds. But as the rogue black hole creeps closer, the peace begins to fracture. Neptune twitches first. Uranus, already tilted and unpredictable, starts spinning with a nervous flare. Even Pluto, once the shy outcast of the planetary family, seems to be acting up again, its orbit wobbling like it's trying to get everyone's attention. It's as if the cosmic orchestra suddenly hit a sour note, and the outer planets are the first to hear it. The first major change comes in the form of orbital resonance disruptions. Normally, Neptune and Pluto are locked in a beautiful gravitational rhythm. Pluto makes 2 trips around the Sun for every 3 of Neptune's. This perfect timing means they never collide, no matter how close their paths seem. It's celestial choreography so precise it would make a Swiss watch blush. But now the rhythm falters. The rogue black hole's gravity nudges Neptune ever so slightly, changing the tempo. That tiny shift sends ripples through the entire system of orbital relationships, like a skipped beat in a metronome that keeps cosmic time. Pluto, ever the dramatic one, responds by swerving off its expected course. For the first time in billions of years, the old dance partners are out of sync. Neptune's normally placid clouds begin to churn with strange patterns. The deep blue giant is used to being cold, calm, and distant, but now it feels invisible fingers pulling at it from across the void. Tidal forces, subtle but insistent, start to stretch the planet's gaseous layers. The distortion isn't something a human eye could spot from afar, but deep within Neptune's atmosphere, the balance of pressure and temperature begins to tilt. Winds grow fiercer, storms brew faster, and the planet's once stable weather system turns turbulent. Somewhere, a methane cloud the size of Earth spins itself into chaos, a quiet testament to gravity's unrelenting reach. Next comes Uranus, the cosmic oddball of the family. Already tilted a dramatic 98 degrees on its side, it rolls around the sun like a planet that forgot how orbits work. But even Uranus, eccentric as it is, notices the disturbance. The gravitational tides reaching it from the approaching black hole begin to stretch its orbit like taffy. Tiny shifts in its axial tilt throw off its equilibrium, and the planet begins to wobble. Scientists on Earth would later describe this as a precession instability. The rest of us might describe it as Uranus having an existential crisis. If planets could talk, Uranus would probably mutter, "I was already spinning sideways. Now I'm just panicking in style." While Uranus rolls and Neptune rages, Pluto, small, distant, and perpetually sulking about its planetary demotion, experiences its own upheaval. Its tenuous nitrogen ice surface begins to fracture under new gravitational stresses. Every few decades, Pluto's thin atmosphere freezes and falls to the ground like cosmic snow, only to evaporate again as it nears the sun. But with the black hole's influence warping its orbit, that delicate cycle is thrown into disarray. Pluto's icy plains start to heave and crack. Geysers of nitrogen bursting upward like silent screams from the frozen world. Somewhere in the Kuiper Belt, Pluto's moons tug uneasily in their orbits, as if bracing for whatever's next. Astronomers on Earth are glued to their instrument. Observatories from Hawaii to Chile are feeding non-stop data to frantic teams of astrophysicists. Every night brings new surprises. A planet slightly off position, a moon orbiting faster than it should, a comet flung off course. Equations that once modeled the solar system with precision now need corrections every few hours. Computers that were once sure of themselves are suddenly spitting out probabilities instead of predictions. The solar system has entered the chaos zone, a place where gravity plays dice and the usual rules stop applying. And the strangest part? Even with all the turmoil, no one can see what's causing it. The black hole remains utterly invisible, its presence known only through the mounting evidence of its influence. It's as though a ghost hand is plucking the strings of our cosmic symphony, each pluck sending a vibration we can feel but not see. Humanity's most powerful telescopes stare into the region of space where the anomalies point. But there's nothing, just blackness upon blackness. Meanwhile, the effects on the outer planets compound. The gravitational tides are stretching them slightly, reshaping their magnetic fields and subtly heating their cores. Neptune's faint ring system, made of icy dust and rock, begins to disperse unevenly, like a halo blown out of shape by a passing wind. Uranus's moons, tiny, loyal companions with mythological names like Titania and Miranda, begin to feel the strain. Their orbits shift minutely, and tidal flexing stirs their interiors, releasing trapped heat. If there's any hidden liquid beneath their crusts, it now churns like a stirred cauldron. And, beyond them, in the deep freezer of the solar system, the Kuiper Belt erupts into motion. Frozen worlds collide. Comets ricochet off each other. The gravitational pull from the rogue visitor creates miniature catastrophes everywhere it touches. It's like a cosmic version of shaking a snow globe. Beautiful, chaotic, and utterly irreversible. For the people of Earth, watching all this unfold from the safety of the inner solar system, there's a haunting realization. Everything out there is changing faster than anyone thought possible. The black hole hasn't even reached the heart of our neighborhood yet, and already the outer worlds are losing their balance. Neptune's calm blues now hide roiling storms. Uranus's serene spin has turned erratic. Pluto trembles at the edge of the abyss. In the grand ballet of the cosmos, these planets are the canaries in the coal mine. Their orbits, their movements, their very shapes are the first notes of a warning symphony playing out across the solar system. The rogue black hole hasn't spoken yet, it's only whispered. But its whispers are enough to shake giants, bend orbits, and remind us that even the grandest planets are just dancers at the mercy of an unseen conductor. And as the black hole keeps drifting closer, one question begins to echo through every observatory, every control room, every sleepless scientist's mind. If the outer planets are already losing their rhythm, what happens when the music reaches us? At the very edge of the sun's influence, where light fades into the cold silence of interstellar space, lies an enormous, invisible fortress of ice and rock, the Oort Cloud. It's not a neat, tidy structure. It's a vast spherical shell of frozen debris stretching almost halfway to the nearest stars. Each of its countless fragments is a leftover from the dawn of the solar system, a cosmic junk drawer of ice-coated relics. For billions of years, these frozen bodies have been dozing quietly in the dark, undisturbed by the drama unfolding closer to the sun. But then comes the disturbance, the gravitational ripple of the rogue black hole, and the long peace of the outer deep is shattered. At first, the change is subtle. Gravity, patient as ever, starts to whisper through the void. The black hole's pull reaches out like invisible fingers, brushing against the outer edges of the Oort Cloud. Those tiny nudges are enough to wake the sleeping giants. One by one, chunks of ice and rock begin to shift. Some start drifting toward the sun, following faint new paths carved by the passing gravity well. Others collide, breaking apart into smaller fragments. Slowly, the Oort Cloud begins to churn. If you could stand at the edge of this colossal field, and let's be honest, you wouldn't want to, you'd see a frozen blizzard of motion. Great icy boulders, once motionless for eons, now inch into new trajectories, gathering speed as they fall sunward. The Kuiper Belt, closer in, joins the chaos. Once a relatively calm band of dwarf planets, asteroids, and comets beyond Neptune, it's now a billiard table after a bad break shot. Objects bump, ricochet, and scatter. Gravity, that usually disciplined architect, has suddenly decided to play without blueprints. It would begin quietly from Earth's perspective. The first signs might be an unusual increase in comet sightings, just one or two at first, nothing too alarming, but then dozens, then hundreds. Night after night, new streaks of light would appear across the sky, their icy tails glowing faintly as sunlight vaporized their frozen surfaces. Amateur astronomers would have a field day. Headlines would bloom with poetic optimism. A celestial spectacle. Comets fill the sky. For a brief, naive moment, humanity would marvel at the beauty, not realizing the danger it represents. Because beauty, in this case, is just physics with sharp edges. Those comets, magnificent as they are also missiles. Each one is a mountain of rock and ice moving at tens of kilometers per second. And they're not all headed harmlessly away. Some are on collision courses with planets, moons, or, uncomfortably, Earth itself. The black hole doesn't need to hurl them directly, it just needs to nudge their orbits ever so slightly, and the sun does the rest, pulling them inward like moths to a fiery lamp. Telescopes would soon record more incoming trajectories than humanity's defenses could even dream of handling. The data would look like a storm forecast, except the raindrops are icy boulders the size of skyscrapers. Space agencies would scramble to calculate impact risks, trying to identify which ones might threaten Earth. But the problem is colossal. Millions of comets, each moving unpredictably, each with its own chaotic spin and speed. It's like trying to predict which snowflake in an avalanche will hit you first. As the weeks pass, the spectacle intensifies. The night sky becomes a gallery of luminous arcs. Long, glowing tails stretch across the heavens, weaving through constellations. Some comets pass close enough to the sun that their tails blaze brightly enough to be seen in daylight. It's beautiful. It's terrifying. It's like the universe decided to put on a fireworks show designed by someone who never heard of fire codes. The comets that survive their fiery passes loop back into the solar system, many now in unstable orbits that cross paths with planets. Mars gets peppered first. Nothing cataclysmic, but enough to make its thin atmosphere glow faintly with streaks of light. Jupiter, the solar system's giant vacuum cleaner, starts gobbling up comets at a furious rate. Massive impacts light up its upper atmosphere, with flashes visible even from Earth's telescopes. Astronomers call these impact flares, though celestial explosions would be just as fitting. Jupiter's role as a cosmic shield becomes both awe-inspiring and horrifying, each impact reminding us how easily one of those visitors could have been aimed our way. In the outer solar system, smaller moons and dwarf planets don't fare as well. Surfaces once pristine are suddenly pockmarked with new craters. Some impacts are so violent they fling debris into new trajectories, creating temporary rings of shattered ice around minor worlds. It's the solar system's version of a chain reaction. One strike leading to 10 new wanderers, all of them heading somewhere unpredictable. Meanwhile, Earth's scientists begin to notice a subtle but alarming trend. Some of the new cometary paths intersect the inner solar system's zone. They start running simulations, each more grim than the last. While most of the comets will miss, a few won't. The likelihood of impacts climbs with every passing week, and even if none hit directly, the sheer volume of material entering the inner solar system increases the risk of smaller debris colliding with satellites, space stations, and spacecraft. Suddenly, humanity's once safe pocket of space looks a lot more crowded, and a lot less forgiving. The irony, of course, is that this entire display is a side effect. The black hole doesn't care about the comets it's disturbing. It's not aiming them, not plotting destruction. It's just passing by, and the laws of gravity are doing what they always do, rearranging the universe in its wake. It's nothing personal, just physics being physics. For the people on Earth, though, this would be a moment of wonder mixed with dread. The night sky, filled with glowing trails, would look like the heavens themselves were unraveling. Poets would call it beautiful. Scientists would call it catastrophic. And, somewhere, a tired astronomer would sip a cold cup of coffee and mutter, "Space is gorgeous, right before it tries to kill you." The storm of comets would continue for years, maybe even decades, long after the black hole had moved on. It would leave behind a solar system permanently altered, new scars on planets, new debris fields, new orbits forged by chaos. The night sky, once predictable, would tell the story of that passing monster for millennia. And as the comets fade, one thought would remain. If a simple brush of gravity could unleash this kind of chaos, what happens when the black hole gets even closer? It begins quietly, as all terrifying things do. There's no flash, no sudden cataclysm, just a slow, creeping weirdness. The kind that makes scientists furrow their brows, news anchors stumble over their scripts, and farmers look up at the sky and mutter, "That's not right." Earth, which has spent billions of years spinning in reliable rhythm, suddenly feels off. At first, it's the seasons. Summer overstays its welcome in one hemisphere, while winter shows up late and then refuses to leave. Crops bloom at the wrong time. Birds migrate in confused patterns, and meteorologists start sounding like fortune-tellers instead of experts. Weather forecasts become guesses disguised as confidence. The jet stream begins meandering unpredictably, carving bizarre climate patterns across continents. Unprecedented becomes the word of the year, used so often it loses its meaning. Then the tides begin acting strange. Coastal communities notice it first. Fishermen who've worked the same shores for generations realize the water's not behaving like it used to. High tides creep a little higher each week, while low tides pull back further than anyone remembers. The moon, that steadfast companion that's kept the oceans dancing for eons, seems to be leading the waltz with a new rhythm. At first it's subtle, centimeters of difference, nothing alarming, but soon it's measurable in meters. Beachfronts flood on clear days. Entire harbors become unnavigable. Somewhere, an oceanographer looks at the data, blinks twice, and spills their coffee. Meanwhile, astronomers begin comparing notes. Across observatories worldwide, the moon's orbit shows a faint irregularity, barely perceptible at first, but growing with each lunar cycle. Its distance from Earth fluctuates in strange ways, not matching any known gravitational influences. Satellite engineers notice that orbital corrections for spacecraft are becoming more frequent, as if something unseen is tugging ever so slightly on the space around our planet. The solar system's perfect geometry is warping, and the distortion is starting to touch home. Still, no one is ready to blame a black hole. That's science fiction, until the evidence becomes undeniable. The first real clue comes from deep space telescopes monitoring gravitational lensing, astronomers spot an anomaly, a subtle bending of starlight in a region of the sky that shouldn't be bending anything. It's as if space itself is breathing, stretching, and contracting. The data looks wrong, but wrong in a very specific, terrifying way. Teams across the world double-check the results, calibrate instruments, and confirm the same thing. Something massive, invisible, and moving fast is warping space-time near the outer solar system. The realization spreads like a cold wind through the scientific community. On Earth, governments hold emergency meetings. Space agencies issue careful statements, the kind that sound calm but feel like holding your breath underwater. An anomalous gravitational distortion has been detected, they say. There is no cause for immediate concern, which, in scientist speak, translates roughly to, "We are extremely concerned." The media explodes, of course. Some outlets call it the cosmic visitor. Others prefer the gravity ghost. Conspiracy theories bloom overnight. There are live streams counting down to imaginary impact dates, internet forums filled with homemade calculations, and doomsday preppers dusting off their bunkers. Yet, amid the noise, real science continues. Telescopes lock on, satellites reposition, and physicists start crunching equations that make their heads ache. The distortions grow stronger. Laser interferometers, the same instruments once used to detect gravitational waves from colliding black holes, now pick up continuous fluctuations. The readings suggest that the space-time near Earth isn't stable anymore. It's rippling, like a pond brushed by an unseen breeze. It's the kind of discovery that would win Nobel Prizes in any other circumstance, if it weren't also terrifying. And then, Earth itself begins to respond. The planet's rotation slows by an imperceptible fraction. Days lengthen by milliseconds, but it's enough to throw off high-precision systems, GPS networks, atomic clocks, satellite communications. Suddenly, time, the most constant thing in human experience, feels slightly different. It's as if the universe reached over and nudged the clock, just to remind us who's really in charge. Geophysicists notice subtle changes in the planet's gravitational field. Instruments detect fluctuations that can't be explained by tectonic movement or atmospheric shifts. It's as if gravity itself is being modulated from afar, tweaked by a force no one can pinpoint. Earth's core, always in delicate motion, might even be responding. Iron currents shifting fractionally under new gravitational stress. No one knows for sure, but simulations suggest it could lead to increased seismic activity. Somewhere, a volcano decides to join the conversation, erupting without warning, as if the planet itself is anxious. Even the night sky begins to look different. Constellations that have guided humanity for thousands of years appear slightly distorted, their stars refracted by the faint bending of light across space. Astronomers describe it as a gravitational mirage. For ordinary people gazing up, it just feels wrong, like reality is being projected onto a screen that's starting to wrinkle. And then, one sleepless night, the truth finally drops. Data from multiple observatories confirms the impossible. The gravitational source isn't just nearby. It's moving closer, straight toward the sun. A rogue black hole, likely wandering for millions of years through the galactic void, is now entering our cosmic backyard. Humanity collectively pauses. Languages differ, but the reaction is universal. Oh no. From that moment on, the tone shifts. Scientists who once spoke in cautious optimism now speak in equations full of dread. The black hole's trajectory is refined with every hour, and its mass estimated to be several times that of the Sun. If it passes close enough, it won't collide, but its gravitational field could distort everything we know. On social media, humor becomes humanity's armor. Memes spread faster than light. The universe just hit randomize on our solar system, says one. Earth's warranty expired, jokes another. But beneath the laughter is a shared unease, a primal understanding that something far beyond human power is approaching. And through all the noise, one haunting image circulates across every screen. An artist's rendering of the black hole, an invisible sphere surrounded by a distorted halo of light gliding silently through the stars. It looks peaceful. It looks almost elegant. And that's the worst part, because everyone now knows that the calm won't last. The data is irrefutable. The distortions are growing. The tides are restless. The moon's path is off by a fraction that matters far too much. The universe has knocked politely on Earth's door. And for the first time in history, we understand what it means when space itself decides to visit. The moment the truth goes public, Earth does what Earth always does when faced with an existential crisis. It opens a debate. Humanity can't even agree on pizza toppings, but now it's trying to decide how to negotiate with a black hole. Within hours of the official confirmation, a massive gravitational object is on a trajectory toward the solar system. The planet splits into camps. Scientists, politicians, philosophers, and the chronically online all have opinions. And, as it turns out, the louder the opinion, the less anyone seems to know what to do. Every major news network broadcasts emergency panels of experts. The headlines are dramatic. Can we survive the black hole? NASA versus nature, humanity's greatest test. The tone, however, wobbles between hopeful and hopeless. Physicists in crisp suits try to explain that the black hole won't necessarily destroy everything. It depends on how close it comes. Politicians nod gravely, then immediately ask, "Can we, move something?" And somewhere off camera, an engineer sighs into their coffee. The first proposal comes, naturally, from the most optimistic among us. Some argue that with enough ingenuity and global cooperation, humanity could fire massive propulsion systems to subtly shift Earth's orbit, just enough to avoid the worst gravitational distortions. It's a noble idea, full of mathematical beauty and complete impracticality. The energy required to move an entire planet, even a tiny fraction, is astronomical. One physicist sums it up perfectly. You'd need every rocket we've ever built, running for 1,000,000 years and maybe a polite prayer. Still, the idea catches fire. Talk shows buzz with speculation. Billionaires post cryptic tweets about Project Arc Drive. Someone launches a crowdfunding campaign titled Move Earth 2025, which somehow raises billions overnight despite offering no actual plan beyond trust us. Meanwhile, engineers run simulations that all end the same way. Earth's orbit barely budges, the propulsion systems melt, and the black hole doesn't even notice. Then comes the second camp, those who believe we should focus on defense. If we can't move Earth, perhaps we can protect it. These thinkers propose launching enormous magnetic shields, building asteroid-sized deflectors, or detonating nuclear blasts to push back against gravitational tides. The scientific community quickly labels these plans ambitious, which is the polite way of saying completely absurd. Gravity, after all, doesn't care about explosions or bravado. You can't shoot a missile at spacetime. Still, the debates rage on. The United Nations calls an emergency summit, now nicknamed the Cosmic Council. Delegates from every nation gather under the symbolic blue flag, hoping to craft a global strategy. The speeches are long, the applause polite, and the outcome inevitable. Committees are formed. Subcommittees are formed to study those committees. Meanwhile, the black hole continues its steady approach, utterly indifferent to bureaucracy. Then, as with every crisis in human history, someone suggests we leave. The evacuationists argue that we should pour all resources into building generation ships, massive, self-sustaining arcs capable of ferrying humanity to another star system. The concept is breathtaking in ambition and terrifying in scale. Even with the most advanced propulsion, reaching the nearest potentially habitable star would take tens of thousands of years. And yet, for many, it's better than doing nothing. Space agencies begin sketching plans. Science fiction writers are suddenly treated like prophets. Elon Musk trends again. But another group emerges, the stay and study crowd. They argue that this is humanity's greatest scientific opportunity. Never before has a black hole passed so close to civilization. We could observe it up close, learn from it, maybe even understand physics on a level never achieved before. Why run from history? One scientist declares. This is our chance to meet the cosmos face to face. Their enthusiasm is admirable, though slightly undermined by the fact that meeting the cosmos face to face could also mean being ripped apart atom by atom. The debates spill beyond science and politics. Philosophers start asking the big questions. What does it mean if humanity's entire existence can be undone by a silent wanderer in space? Religious leaders interpret the event through the lenses of prophecy and purpose. Environmentalists, with grim irony, point out that the universe seems to be giving us a very literal reminder of how small we are. As days turn into weeks, the arguments grow increasingly absurd. One late-night host jokes, "Scientists say we might alter planetary orbits. Politicians say we can negotiate with gravity. Somewhere, the black hole is just watching and thinking, bless their hearts." Memes spread faster than data. One popular image shows a group of ants holding up tiny protest signs that read, "Stop the boot." Because really, that's what it feels like. Ants arguing about how to stop a boot that hasn't even noticed them. In universities, lectures overflow with students eager to be part of this moment in history. In private labs, engineers toy with ideas for planetary thrusters. In underground bunkers, billionaires quietly begin funding private escape projects. Humanity is reacting to the cosmic crisis exactly as expected, half with brilliance, half with chaos. Eventually, consensus begins to form, not on what to do, but on what not to do. Direct interference with Earth's orbit is deemed impossible. Defensive measures are ruled out as futile. The only realistic approach, scientists agree, is observation, preparation, and, well, hope. The goal shifts from survival to understanding. If nothing else, we can document our demise in exquisite detail. The press conferences take on a strangely philosophical tone. We cannot stop the laws of physics, one scientist says softly, but we can bear witness to them. Another adds, if this is our fate, then let it also be our experiment. It's the kind of statement that makes the front page of every paper, partly because it's profound, and partly because no one has a better idea. In the midst of it all, humanity keeps living. Children go to school, couples fall in love, people argue online about trivial things. The sun still rises, the black hole still approaches, and the species that once believed it could conquer anything now finds itself humbled by silence and math. And somewhere late at night, a physicist gazes up at the stars and thinks, maybe that's the point. Maybe, in the grand scale of the universe, the most human thing we can do isn't to win, but to wonder. For 4.5 billion years, the sun has been the undisputed ruler of our cosmic neighborhood. Every planet, moon, and drifting piece of space debris has orbited obediently around its blinding authority. It's the gravitational monarch, the fusion furnace that dictates the rhythm of life itself. But even kings can tremble. And as the rogue black hole creeps closer, the sun, our mighty, unchallenged star, starts to feel something it has never experienced before: competition. It begins subtly, deep within the sun's core, where hydrogen fuses into helium under unimaginable pressure. Everything still seems normal. The outward push of nuclear fusion perfectly balances the inward pull of gravity, maintaining the delicate equilibrium that has burned steadily for eons. But outside that blazing heart, in the layers of plasma that stretch toward the surface, strange things start to happen. The sun's magnetic field, normally a tangled but stable mess of loops and arcs, begins to twitch. Solar plasma currents shift, slightly but perceptibly, as if pulled by invisible threads stretching across millions of kilometers of space. The black hole's gravity doesn't need to come close to have an effect. Its mere approach is enough to create subtle distortions in the sun's magnetic structure, like distant thunder rumbling through the skin of a drum. The sun's plasma, a boiling sea of charged particles, starts to slosh unevenly. It's not catastrophic, not yet, but it's enough to disturb the regular cycle of solar flares and coronal mass ejections. The sun, once the most predictable thing in the sky, begins to act erratically. Astronomers are the first to notice. They observe a sudden uptick in solar flare activity, massive bursts of energy leaping from the sun's surface in every direction. Normally, solar storms follow an 11-year rhythm, tied to the waxing and waning of magnetic polarity. But now, the rhythm is gone. The sun starts firing off flares at random, as though its internal compass is spinning out of control. It's like watching the universe's most powerful light bulb flicker, one scientist remarks grimly. Soon, the chaos reaches Earth. Satellites begin to suffer from radiation interference. GPS networks glitch. Auroras bloom across latitudes that have never seen them before. Neon curtains of green and red dancing over the deserts of Africa, the jungles of South America, and the city lights of Tokyo. For a brief moment, humanity stands outside at night, gazing upward in collective awe, unaware that these glowing skies are not a gift, but a warning. Inside the sun, the magnetic turmoil grows. Great loops of plasma, shaped by invisible magnetic fields, twist and snap like rubber bands stretched too far. Each release sends titanic eruptions of energy into space, waves of charged particles screaming outward at millions of kilometers per hour. The solar wind, once steady and directional, turns erratic, its streams colliding and merging into turbulent fronts. For the planets orbiting nearby, it's like living downstream from a raging furnace that has suddenly decided to change its temperature every hour. The black hole's gravitational pull, faint but relentless, begins to tug on the sun's outer layers. It doesn't rip or tear. Gravity is more elegant than that. Instead, it stretches space-time itself around the sun, subtly elongating its sphere into an imperfect shape. Astronomers describe it as a tidal bulge, though that term feels far too polite for what's happening. The sun, that blazing constant of human existence, is literally being warped. Solar physicists watching from observatories describe the behavior as unprecedented. They notice that the sun's oscillations, its rhythmic vibrations that scientists use to study its interior, are becoming irregular. The star is, quite literally, trembling. In some regions, magnetic polarity flips prematurely, creating patches of instability across its surface. The normally calm equatorial regions become hotbeds of activity, peppered with sunspots that bloom like cosmic bruises. From space, the view is breathtaking and horrifying. Solar flares shoot out in tangled arcs, dwarfing entire planets, while waves of plasma ripple across the surface like shock waves from an unseen explosion. The sun, which has spent billions of years sculpting the harmony of the solar system, now seems to be fighting to maintain control. It's losing a tug-of-war with an enemy it can't even see. The energy output fluctuates. Radiation levels spike unpredictably, throwing off the delicate balance that sustains planetary climates. On Earth, satellites fry, power grids short out, and communication networks flicker like candlelight. Even astronauts aboard space stations retreat into shielded modules as radiation storms surge past, each one an echo of the sun's growing instability. And yet, amid all the chaos, there's a strange kind of majesty in it. The sun, wounded but defiant, burns even brighter. Its flares become more spectacular, its corona more luminous. It's as if our star is raging against the cosmic intruder, fighting to prove it's still the center of everything. Astronomers can't help but anthropomorphize. The sun isn't just reacting, it's protesting. Meanwhile, scientists back on Earth scramble to model what's happening. Their computers spit out incomprehensible graphs and error messages. Magnetic field simulations break down under the sheer complexity of the interactions. The sun is no longer in equilibrium, one researcher mutters during a live broadcast, her voice trembling slightly. We're watching it struggle. And that's exactly what it is, a struggle. A battle of gravity against fusion, of starlight against the void. The black hole doesn't roar or strike, it merely bends reality in its quiet, merciless way. The sun, for all its might, can only respond with fire. As the black hole draws closer, the solar storms intensify. streams of plasma stretch further into space, some of them snapping loose and drifting off entirely. For the first time, the heliosphere, the vast bubble of solar wind that shields the solar system from interstellar radiation, begins to wobble. The invisible boundary that defines the sun's domain is flickering, shrinking, and reshaping under the black hole's unseen influence. The empire of light is retreating, and so the star that has reigned supreme for billions of years now faces an invader it cannot burn, cannot blind, cannot outshine. The sun's fusion heart still beats, but its once perfect harmony is faltering. It's as if the universe itself is reminding our star of its place in the grand hierarchy. Just another light among countless others, all equally vulnerable to the quiet pull of gravity. The sun, once the boss of our neighborhood, now looks less like a ruler and more like a fighter backed into a corner, burning brighter, flaring harder, and losing ground one wave of plasma at a time. If the outer solar system was the first to sense the black hole's approach, the inner planets are now the ones feeling its fury. The delicate orbits that have held steady for billions of years begin to shift, wobble, and stretch as gravitational tides ripple inward from the sun's increasingly unstable domain. It's as if the universe took the cosmic mobile hanging over the sun's crib and gave it one big, mischievous push. The first to feel it is Mercury, the tiny, scorched messenger of the gods, perpetually locked in a frying orbit closest to the sun. Normally, Mercury's dance is tight and predictable, looping around every 88 days like clockwork. But now, that clock starts running wild. The black hole's distant tug amplifies the sun's own fluctuations, causing the inner gravitational field to fluctuate like a skipping record. Mercury's orbit starts to elongate, stretching it closer to the sun during perihelion. With every pass, tidal forces grow stronger. The planet begins to spiral inward, inch by inch, toward the inferno that birthed it. To an observer watching from afar, Mercury's demise would be beautiful in a horrifying way. The planet's surface, already baked by relentless sunlight, begins to peel apart as solar radiation doubles and triples. Waves of molten rock ripple across its surface. The black hole isn't pulling Mercury apart directly. It's merely changing the sun's gravity enough to throw everything off balance. It's cosmic dominoes, and Mercury just happens to be the first to fall. Venus fares no better. For centuries, it's been called Earth's twin, though that comparison has always been the kind of compliment you give when you're trying to be polite. Venus's thick, suffocating atmosphere, rich in carbon dioxide and thick clouds of sulfuric acid, has long made it a cautionary tale of runaway climate change. But now, the black hole's interference turns that already hostile environment into a planetary tantrum. The sun's erratic flares bombard Venus's upper atmosphere, stripping away layers of gas in violent bursts. The magnetic shielding that once offered some protection from solar wind collapses. What was once a thick, swirling cocoon becomes shredded ribbons of ionized plasma. Enormous lightning storms light up the planet's surface, striking through the haze like the flickering of a dying bulb. If planets had emotions, Venus would be screaming, and every burst of radiation from its sun-scorched clouds would be its voice. Earth, meanwhile, begins to notice the effects in ways far more personal. The gravitational balance that keeps our orbit stable starts to teeter. It's not enough to fling the planet out of its path, but it's enough to make every day feel slightly off. The moon's orbit, already behaving strangely, starts pulling tides higher than ever recorded. Oceans rise, coastlines vanish, and entire regions experience months of flooding followed by extreme drought. The climate system, delicate even at the best of times, can't cope. Weather patterns spin out of control. Storms appear where they shouldn't. Seasons overlap, and jet streams twist into knots. At night, the sky becomes a show unlike anything humans have ever seen. The debris flung into new orbits by shifting gravitational forces starts to glow as it burns through the upper atmosphere. Meteors streak across the heavens in constant showers, lighting up the darkness in crimson and gold. Astronomers call it an apocalyptic aurora, a celestial fireworks display marking the solar system's nervous breakdown. The view is stunning, but the context is grim. As one scientist quips during a live broadcast, it's the universe's way of turning off the lights after a long party. Mars, our hopeful red neighbor, doesn't escape unscathed. Its orbit, already elongated compared to Earth's, becomes erratic. The black hole's gravitational influence, combined with the Sun's magnetic chaos, begins to tug at Mars's path, stretching it into unpredictable loops. The once calm Martian skies fill with dust storms so large they wrap around the planet. The faint atmosphere, stripped further by solar radiation, thins even more. Robotic probes and satellites, those brave little machines humanity sent to explore, start losing contact one by one, their signals fading into static. For the first time in history, Mars goes silent. On Earth, panic becomes the new normal. Governments issue emergency bulletins, but no one knows what to say. Farmers can't predict planting seasons anymore. Power grids flicker under geomagnetic interference. GPS systems lose accuracy as the planet's orbit wobbles. People look up at the sky, confused by the eerie, unending light shows that dance above. Some mistake them for divine signs, others for the end itself. Religion and science briefly overlap in a shared expression of awe and helplessness. And yet, amid the chaos, humanity continues to document, to observe, to try to understand. Telescopes record the shifting glow of the sun's surface. Seismographs capture faint vibrations in Earth's crust that might, just might, be connected to the subtle gravitational stresses building within. Satellite data paints a picture of a solar system unraveling. Orbital lines, once circular, now stretch like pulled threads on a cosmic tapestry. Even the asteroid belt, long a quiet graveyard of ancient rock, joins the madness. Perturbed by the new gravitational dynamics, fragments begin to drift out of formation. Some are sent hurtling inward, sparking fiery streaks in Earth's atmosphere. Others are flung outward, lost to interstellar space. Space itself seems restless. Back on Earth, the night sky that once brought comfort now carries dread. The constellations, slightly distorted by the bending of spacetime, seem unfamiliar. Astronomers notice that the positions of planets are shifting faster than their calculations predict. It's as if the universe's most precise clock has started to skip beats. And somewhere out there beyond Mars's restless orbit, the black hole continues its approach, silent, invisible, patient. The inner planets are now caught between two giants, the sun, flaring and faltering under stress, and the black hole, calm and steady in its devouring pull. It's a gravitational duel, and the smaller worlds are collateral damage. As Earth spins under an increasingly chaotic sky, one truth becomes clear. This isn't just astronomy anymore. It's survival. The solar system, once a picture of cosmic order, has turned into a battlefield of gravity and fire. And the star that gave us life is no longer a guardian. It's a warning beacon, flickering in the face of something it cannot overpower. The planets, for all their grandeur, are nothing but dancers caught in a storm of invisible strings. And with each passing moment, the music of the solar system plays faster, louder, and more chaotically, until it feels like the final movement of a cosmic symphony that's about to end in silence. In the beginning, there is silence. Not peace, just silence. The kind that comes before the world itself begins to break. The black hole, once a distant specter, is now close enough for its presence to dominate everything. Space around it bends and twists visibly, like a mirage of warped starlight. From Earth, it doesn't appear as a whole, but as a distortion, a dark lens surrounded by a halo of light, bending the stars into a shimmering whirl. It's beautiful in that quiet, horrifying way beauty often is, and beneath that spectacle, Earth begins to die. The first to betray the planet are the tides. For billions of years, the moon has been the choreographer of Earth's oceans, pulling the seas gently back and forth. But now a new dancer joins the stage, a black hole whose gravitational grip makes the moon look like a pebble skipping across water. Oceans rise in defiance of gravity's old order. Coastlines vanish beneath walls of water that tower higher than skyscrapers. Entire continents begin to drown not in waves, but in slow motion ascents. Seas climbing upward as though the planet itself were tilting into the void. People flee, but there's nowhere to go. There's no high ground when gravity itself is pulling in directions it never did before. The oceans no longer obey the curve of the planet, and they surge toward the sky in shimmering curtains of vapor and spray. Satellites capture the horrifying elegance of it, the Earth's surface rippling like liquid under the strain, the Pacific and Atlantic swelling toward each other as the globe begins to stretch. Next, the crust fractures. Deep beneath the surface, molten rock responds to the stress. Tectonic plates, once content to drift at geological pace, start lurching in violent spasms. Mountain ranges collapse into valleys. Valleys burst upward into ridges. Volcanoes ignite across fault lines like matches striking all at once. Entire chains of fire ring the planet, spewing ash that glows red under the strange new sky. Earthquakes ripple across every continent, their waves overlapping into a global vibration that makes the planet itself hum. To the people still alive, it's as if the world has become both ocean and fire. Everything fluid, everything unstable. Cities crumble not from impact, but from being pulled apart, each building stretched just slightly faster than it can stay whole. Bridges elongate, metal groans, glass shatters under invisible pressure. Gravity has turned cruel, pointing in directions no compass can follow. And then, the air itself begins to betray us. The atmosphere, once clinging loyally to the surface, starts to rise. The black hole's gravity is so immense that even air cannot resist being pulled upward. The sky fades to thin, then to none. The blue that has defined human existence dissolves into black. Winds reach impossible speeds as air rushes toward low-pressure regions, shredding everything in its path. Sound begins to vanish. There's no medium left to carry it, though. The planet's last scream is silent. Above, the view from orbit is otherworldly. Earth no longer looks like the familiar blue marble, but like a shimmering teardrop being pulled toward the black hole's distorted light. The planet is literally stretching. Astronomers once coined the term spaghettification to describe what happens when something approaches a black hole. The closer side feels a much stronger pull than the far side, stretching it out until it resembles a strand of cosmic pasta. That's not just theory anymore. Mountains, oceans, cities, and people all are being drawn into long, thin shapes by tidal forces so strong they defy imagination. Congratulations, humanity. We've officially become cosmic spaghetti. It's a grim joke, whispered by one of the last scientists, broadcasting from an underground observatory before the signal cuts out. But in that line, half humor, half resignation, there's a strange comfort. Even facing annihilation, humanity can still laugh, still name the absurdity of existence. If the universe is going to erase us, at least we'll leave behind a punchline. The light show above intensifies. As the black hole draws in the outer layers of the Earth's atmosphere, they ignite into plasma, glowing with colors no human eye has ever seen. Greens, purples, and deep golds ripple across the sky. The aurora of the apocalypse. Fragments of the moon, its orbit long since destabilized, begin to rain down, trailing molten debris through what remains of the air. For a fleeting moment, the sky is both terrifying and divine, as if the universe is signing its name across our destruction. Meanwhile, time itself begins to falter. From a distant vantage point, an observer would see Earth's disintegration playing out in slow motion. The closer the planet drifts toward the black hole, the slower time moves relative to the rest of the universe. For the people caught within it, though, the moments stretch endlessly, seconds feeling like hours, the final collapse drawn out into an eternity of falling. To anyone watching from afar, Earth's last image freezes on the edge of the event horizon, never quite disappearing, caught forever between being and not being. Inside that distorted moment, gravity wins its final argument. The mantle gives way, collapsing inward toward the core. The iron heart of the planet liquefies under pressure and heat, and the black hole begins to unravel what's left, atom by atom. The oceans boil off entirely, leaving behind a steaming void. The crust crumbles into dust and plasma. The magnetosphere collapses, and with it, the last flicker of Earth's protection against the void. What remains is light. a last defiant glow from the shredded remnants of atmosphere and rock. For an instant, Earth shines brighter than it ever has before, a tiny spark against the black. And then it's gone. The black hole swallows the debris in silence. No explosion, no bang, just absorption. The universe doesn't end with a sound, it ends with a sigh. Far away, instruments aboard distant probes still capture the fading radiation, transmitting the final data packets into the endless dark. Somewhere, centuries from now, another civilization might decode those signals and learn about a small blue planet that tried to understand the cosmos and was, ultimately, consumed by it. If they ever do, maybe they'll smile at that one last human joke buried in the data logs. Congratulations, we've officially become cosmic spaghetti. Because even at the end of the world, we stayed ourselves, curious, foolish, funny to the last breath, laughing in the face of infinity as gravity took its final bow. When the black hole finally drifts past, silence returns. Not the peaceful kind that follows a storm, but the hollow quiet of a place emptied of meaning. The solar system, once a clockwork marvel of balance and rhythm, has been gutted and rearranged. What remains is something new, strange and hauntingly beautiful, a cosmic crime scene rewritten by gravity's most ruthless sculptor. The black hole doesn't linger. It never does. It glides on, continuing its endless journey through the galaxy, leaving behind only a warped shadow of what used to be. In its wake, the sun wobbles like a boxer who's taken one too many hits. No longer the proud, centered anchor of its system, it now orbits slightly off-kilter, its path twisted by the gravitational tug-of-war it just endured. Its once spherical shape remained subtly deformed, stretched and scarred from the encounter. To an outside observer, it would appear to pulse faintly, not from brightness, but from instability. The great star that had always been in control now follows an invisible leash, trailing the black hole like a bruised pet starling behind its predator. Where the planets once followed graceful ellipses, now there's chaos. The few survivors, if one can call them that, move through space on eccentric, unpredictable paths. Mars drifts in a warped oval, looping erratically before being flung outward into the cold dark. Venus, stripped to a rocky skeleton, might linger near the sun for a time before slowly spiraling into it. Fragments of Mercury scatter like glitter, remnants of a planet that got too close to the storm. And then there's Jupiter. The gas giant, with its colossal mass and stubborn gravity, holds on better than most. But even Jupiter's fate is uncertain. The black hole's passage sends it careening into a stretched orbit that carries it far from the sun, perhaps even breaking the last thread of its allegiance. For a time, it might orbit as a rogue world of its own, glowing faintly from residual heat, wandering in darkness, a miniature version of the intruder that destroyed its family. The poetic irony would be lost on Jupiter, of course. Planets don't appreciate irony. Beyond Jupiter, the wreckage of the Kuiper Belt and Oort Cloud now stretches into a diffuse halo of debris. What was once a neat boundary marking the edge of the solar system is now a fog of shattered ice and rock, sparkling faintly with reflected light. It's beautiful, in a way, the galaxy's version of a memorial wreath, glimmering softly where the sun's light still dares to reach. But what's most striking is the emptiness, the delicate gravitational dance that once connected every orbit, every tide, every comet. Gone. The solar system has become a collection of orphans, each body moving to its own rhythm, ignoring the old choreography. Some planets are flung outward, gaining enough velocity to escape entirely. They become wanderers, rogue worlds drifting between stars, carrying with them the ghosts of what used to be home. Others spiral inward, doomed to fall into the sun or collide with the debris still spiraling from Earth's disintegration. If an alien civilization were to arrive millions of years later, they would find traces but no story. Perhaps they'd detect the faint remains of the asteroid belt and wonder if it had once been something greater. Maybe they'd notice the sun's erratic orbit around a distant black hole and speculate about the catastrophe that twisted it so. But there would be no sign of humanity, no fossils, no radio signals, just the raw physics of what happens when gravity decides to remodel reality. The space where Earth once existed now glows faintly from residual energy, a thin ring of plasma spiraling outward, fading into nothing. The moon's fragments still drift through the void, colliding and merging into irregular clumps that might, in some far future, coalesce into new moons or minor planets. Creation and destruction are, after all, two sides of the same cosmic coin. In the centuries following the black hole's passing, the sun stabilizes, barely. It continues to burn, though less confidently, its outer layers still rippling from distortion. Its gravitational pull, diminished and twisted, can no longer maintain the perfect balance it once held. The solar system has effectively become a debris field orbiting a wounded star. And yet, there's a strange sort of order forming within the wreckage. Over time, scattered dust and gas begin to gather again, coalescing into new shapes. Gravity, ever patient, begins to rebuild. It doesn't mourn, doesn't remember. It just moves forward, obeying the same laws that caused the disaster in the first place. The universe has no pause button, no undo feature. Even destruction becomes creation if you wait long enough. In this new cosmic landscape, the black hole continues on its path, dragging behind it a distorted arc of matter, traces of the system it just consumed. The sun follows at a cautious distance, caught in a loose, elliptical orbit. Together they become an unlikely pair, a wounded star and the void that scarred it, orbiting one another in uneasy silence. From far away, they might look like a binary system, light and darkness bound together, spinning through the galaxy like a reminder that every victory of gravity is also a theft of order. The irony is that the universe will forget. Stars will rise and die. Galaxies will collide. And somewhere deep in the cosmic timeline, the traces of this encounter will fade completely. The sun, if it survives long enough, will eventually exhaust its fuel and shrink into a white dwarf. The black hole will drift on, indifferent as ever, until it too evaporates through Hawking radiation billions of years later. By then, everything that once was, planets, oceans, laughter, love, will have been folded back into the quiet hum of entropy. No survivors, no witnesses, just physics. But maybe, somewhere within the particles of dust that remain, a photon still travels outward, one last piece of light from Earth's final sunrise, racing through space, untouched by gravity's chaos. It won't carry words or memory, but it will carry existence. Proof that once upon a time, in one tiny corner of the cosmos, life looked up at the stars, named them, and wondered. A cosmic renovation, yes, but with no warranty, no manual, and no one left to admire the work. Just a reshaped system, gleaming faintly under the indifferent gaze of the universe, waiting for whatever comes next. Even after the apocalypse, the universe doesn't stop moving. Destruction is never total. It just changes shape. The black hole has long since vanished into the dark, dragging the echoes of the solar system behind it like a memory fading into static. Yet, scattered among the debris, something remains. Not alive in any familiar sense, but persistent, tiny, tenacious, and utterly indifferent to the concept of endings. The survivors of this cosmic tragedy aren't heroic figures or resilient civilizations. They are microbes, machines, and drifting fragments of history. Bits of matter stubborn enough to keep existing. On the icy moons that once orbited Jupiter and Saturn. Deep beneath frozen crusts, pockets of water may still endure. The gravitational violence that shredded planets and flung worlds apart might have spared these hidden oceans, insulated beneath kilometers of ice. There, in complete darkness, microbial life could cling on, thriving on chemical energy released from their fractured cores. Imagine Europa, cracked and cratered, floating now in a stretched and lonely orbit far from any sun. The ice above it glows faintly with reflected starlight from galaxies beyond, and below that pale shell, the water still moves. Hydrothermal vents bubble on the ocean floor, releasing minerals and heat. Around them, microscopic life forms drift, blind and unaware that everything else has died. They do not remember Earth, nor care about the black hole that ended it. They live because that is what life does. They are the universe's version of stubborn hope, tiny, accidental immortals. And then there are the machines. The probes humanity sent into the dark before the end. Voyager 1, Voyager 2, Pioneer 10 and 11, New Horizons. All of them launched in an age when the idea of interstellar disaster was just the stuff of science fiction. They were meant to be explorers, not survivors. Yet here they are, still drifting, still humming faintly in the emptiness. Long after the last human breath, these little emissaries continue on their trajectories, carrying messages to a cosmos that may never answer. Voyager 1, with its golden record bolted to its side, now glides through a space where the sun's light no longer reaches. Its sensors have gone silent, but the plaque remains. A metal postcard from a vanished species. Engraved upon it are greetings, mathematical diagrams, and the sound of laughter recorded by a civilization that thought it would last forever. Somewhere, Voyager might still be sending postcards to a home that no longer exists. Perhaps, millions of years later, one of these relics passes close enough to a new world, a planet orbiting another star. Its trajectory altered slightly by the faint gravity of some distant system. It coasts inward, becoming a tiny visitor to someone else's sky. Maybe it burns up in an alien atmosphere, its message erased in a flash of light. Or maybe it lands softly, intact, waiting to be discovered by beings with eyes curious enough to ask, who were they? Far beyond the ruins of the solar system, other remnants drift. Asteroids knocked into interstellar space, dust clouds filled with carbon and silicate, molecular fragments that once made up oceans, bones, trees, and satellites. Over time, they spread like a cosmic pollen, mixing with interstellar gas. One day, these fragments might be swept into the birth of a new star system. The atoms that once belonged to Earth could become part of a new world, orbiting a new sun, with new life staring up in wonder. That's the strange beauty of the universe. It recycles everything. Even extinction becomes raw material for creation. And maybe, just maybe, somewhere in the cold void, artificial minds endure. Machines left behind by humans, some on the moon, others buried deep beneath Martian dust, might still function in limited ways. Solar power is gone, but nuclear batteries could continue to hum faintly for centuries before fading. A robotic rover, half buried in sand, might continue to attempt a connection it will never receive, sending out pings into silence. "Hello, Earth," it might whisper into the void, like an echo bouncing off the walls of eternity. If the black hole's gravitational passage didn't destroy everything, then perhaps fragments of data still orbit within wrecked satellites, snippets of human voices, coded instructions, fragments of songs. The electromagnetic ghosts of radio transmissions still drift outward at the speed of light, carrying the memory of our presence into the infinite dark. Some of those waves will continue for billions of years, weak but eternal, expanding across the galaxy. Somewhere, in some unimaginable future, those signals might pass through another civilization's instruments. They'll detect faint bursts of structured noise, patterns that defy randomness, and realize something was here once. That realization would make us, in a strange way, immortal, not in body or civilization, but in trace, in pattern. Humanity's echo stretched thin across time and space, whispering, "We were here. We tried to understand. It's a comforting thought amid the vastness. Even if no one hears it, the message exists, and that's enough." The cosmos doesn't demand to be understood. It only demands participation. And we participated with curiosity, with creativity, with wonder. Among the drifting debris, there might even be beauty. Broken satellites and planetary shards glint with starlight, turning the void into a quiet glitter field. It's no longer a solar system. It's an art installation of cosmic melancholy, a graveyard made of frozen orbits and lost dreams. But if you could float among it, if you could drift silently past what remains, you'd see the story written in every scar. Creation, collapse, and persistence. And so, in the grand scale of things, survival takes on a new definition. Not every life must continue for its story to matter. Sometimes, the remnants are enough. The microbes in their icy tombs, the probes that wander endlessly, the particles that once made poets and planets, now swirling into new beginnings. The universe doesn't mourn. It simply moves forward. But through these remnants, organic, mechanical, and atomic, the memory of a solar system lingers, quiet but unbroken. Humanity may be gone, but its fingerprints are everywhere, smudged across the stars. And as Voyager sails onward into the eternal night, its golden record spinning in the dark, perhaps the last sound it carries, of a human heartbeat, echoes faintly through the vacuum. Not as a plea, not as a cry, but as a gentle reminder that even in the face of oblivion, life once dared to sing. The universe, for all its indifference, is a patient teacher. It doesn't hand out lessons with a syllabus or a smile. It simply exists, vast and silent, and lets us figure out what that means. A black hole passing through our solar system may be the ultimate cosmic nightmare. But, as thought experiments go, it's one of the most humbling. Because imagining that kind of annihilation forces us to confront the fragile miracle of what we already have. A tiny planet orbiting a warm, cooperative star, protected by an atmosphere thinner than the skin of an apple. In the infinite chaos of space, that's not just rare, it's absurdly lucky. So let's sit with that for a moment. The fact that Earth exists at all, spinning comfortably in the habitable zone, is a statistical miracle. Our planet formed in the right place, at the right time, with the right chemistry. The sun burns just hot enough to warm us, but not incinerate us. Gravity holds our oceans in place. The moon steadies our axis, keeping seasons balanced. It's an arrangement so delicate that a single rogue visitor from the stars, a drifting black hole, a misbehaving comet, or even a slightly cranky asteroid, could end it all in a heartbeat. And yet here we are, writing, building, joking, arguing about pineapple on pizza. The universe has given us the perfect setup for consciousness, and we mostly use it to post memes. But maybe that's the point. Humor, after all, is how small creatures cope with enormous truths. When we laugh at cosmic doom, we're not being dismissive. We're practicing perspective. To imagine a black hole erasing our solar system is to remember how temporary everything is, and how miraculous it is that we ever got a turn at all. It's the cosmic equivalent of being handed a glass of water in the desert and realizing you should probably drink it slowly. Thinking about the end of everything also highlights how much we still don't know. Black holes are paradoxes wrapped in equations, a place where our understanding of physics breaks down entirely. They challenge our arrogance as a species that once thought Earth was the center of the universe. Every time we discover one, we're reminded that the universe isn't built for our comfort or convenience. It doesn't owe us survival. But it does offer understanding, for those brave enough to ask questions knowing they might not like the answers. There is something liberating in that realization. Knowing that the cosmos doesn't revolve around us frees us from the illusion of control. We can't stop stars from dying or galaxies from colliding, but we can choose how to live in the time and space we've been given. We can be caretakers of this improbable world, stewards of its brief, shining moment of stability. Maybe that's the real lesson from imagining a black hole tearing through our neighborhood. Take care of the place before the universe decides to remodel it. Because if Earth teaches us anything, it's that fragility and beauty often coexist. We're a planet that has survived asteroid impacts, ice ages, volcanic winters, and the occasional bout of self-destructive human behavior. Life clings on, stubborn and adaptable. The same molecules that built the first cells now make up cities, songs, and satellites. That persistence is proof that while we may be small, we're not powerless. The odds of existing were astronomically low, but we made it anyway. That should count for something. Maybe that's why, even in the face of cosmic catastrophe, our instinct isn't just to fear, it's to wonder. We want to understand how things work, even when they terrify us. We build telescopes to study the void. We send probes into deep space knowing they'll never come back. And we write stories about the end of everything, just to see how it feels to imagine it. That curiosity is our species' greatest strength. It's also our funniest trait. Because deep down, we know the universe is infinitely bigger than us, and yet we keep trying to measure it with yardsticks and enthusiasm. In some alternate future where another civilization finds traces of humanity, our spacecraft, our broadcasts, our scribbled mathematics, they might not remember our wars or our inventions, but they'll know we wondered. That we looked at the stars and asked, what if? And maybe that's enough. Because to ask that question is to participate in the grand conversation of existence. So, yes, a black hole passing through our solar system is extremely unlikely. Statistically speaking, it's one of the least probable disasters we could face. But that is not to the point. The point is that it could happen, and that possibility reminds us of how fragile, how precious, and how temporary our little cosmic oasis really is. Every sunrise is a quiet miracle of orbital mechanics. Every raindrop, a product of gravity and starlight working in perfect tandem. We live on a planet where water flows, light nurtures, and life keeps finding ways to surprise itself. That's worth protecting. Not because the universe cares, but because we do. Maybe that's the ultimate joke of existence. The cosmos doesn't need us, but we care about it anyway, but we build meaning in a place that offers none, and in doing so, we give it meaning. We're the punchline that laughs back at the setup. So, if the universe ever decides to send a black hole our way, maybe the best we can do is greet it with the same mix of awe and absurdity that defines us. We'd look up at the bending sky, feel the pull of gravity on our bones, and say, "Figures, we just got Wi-Fi working properly." And in that moment, between laughter and fear, between the infinite and the fleeting, we'd understand the real lesson from the darkness. That existence isn't about permanence, it's about participation. The cosmos may not remember us, but we were here, we looked up, and we laughed. So take care of your planet. Love it fiercely. Because the next time the universe sends a reminder of how small we are, it won't come as a whisper. It'll come as gravity.